So I'm Chris Andrews. Until last fall, I was the 3D product manager for Esri, but I started as the 3D product manager back in late 2014 as just an individual contributor, and then Don and Eric Whitner started working with me on Don doing BIM and CAD stuff, and then Eric doing urban planning and city engine and things like that. And then as of the end of last year, now our team is up to 10, and there's a whole bunch more stuff that we work with. Don, you want to introduce yourself?
Yeah, I'm Don Keeney. I'm, like Chris mentioned, the product manager for CAD and BIM. Yeah, got lots of stuff.
I should probably put senior product manager there, but I didn't want to make you feel old.
Okay.
No. Don, how long have you been with Esri?
I've been with Esri, what now, 27 years? Working in the space of CAD.
Don was one of the first two product managers at Esri, so he's definitely been, it's really cool actually. He's probably like one of the first like 50 product managers in the whole software industry, so there you go. It's really good stuff. All right. So am I going to advance? Okay. So I've started adding this simple safe harbor statement. Oops. Okay. Is it gonna, all right. Let me know if this blinks. I've started adding this simple safe harbor statement. I think Esri will probably have a few more things like this in the future. I'm happy to talk about future stuff, but you just need to understand that you can't blame us later if you make a business decision and we change our minds. It's pretty standard at other companies, and we're starting to see Esri professionalize a little bit like that. The team that Don and I work with, if you look at it from one direction, we're called the Focused Products and Geo-Enabled Systems team, which is a mouthful. But if you look at the product areas from a different direction, it's actually kind of the entire smart cities and project delivery story. So we cover apps for EMS, police and fire. We cover apps for asset inspection. We cover apps for urban planning, utility, parcels, AEC CAD BIM, a variety of stuff in the team that we have. And we're expanding quite a bit, and we're going to be doing more. Jack and others talked this week about the geospatial cloud being kind of the not just rebranding, but reformulation of kind of our core technologies for on-premises or cloud-based delivery of geospatial capability anywhere across large organizations. And then there's this other thing, which is they talked about, which is that we also are recognizing more and more, and I've recognized this since I started my career, but that many people who use GIS information never want to spell GIS or hear GIS used. And so these systems are largely focused on people who really don't care about GIS, they're just trying to get a job done. And we hopefully will see more come out of our group around that kind of concept. All right, so actually a quick question. How many people, and wow, this is like double the audience I expected for Friday morning, so it's great. How many people here know how to spell BIM? All right, how many people here really don't feel comfortable with or that they know what BIM is really well? All right, so we have a few, okay. Come on, Steve, you work at HDR and you don't know what BIM is? You're BIM. Absolutely true. That's absolutely true. It does help to have that to have a definition though. So I'll walk quickly through kind of what my definition is, and it's been kind of forge tested with no pun intended again with Autodesk and others, and it's definitely it's working. All right. So if we look out at around 2030, we can see that there are some big numbers and one small number that are going to impact us. So there are supposed to be 8.5 billion people on the planet by then. There are actually supposed to be around 125 billion connected devices influencing something like $4 trillion in market activity. It's ridiculous. And actually the internet connected device you see there was built by a team of 3rd through 5th graders working with me. So, and it was a baby monitoring device. Oh, come on. You know what, Don, do you mind if we switch over to just swap out one? Because this is...
We're switching video cables.
Yeah. And I think it's just the cable, because, yeah, all We'll switch back. So I worked with a team of kids to build a device that was actually a baby monitor that had video and temperature and vibration and all kinds of stuff. So if a team of kids can do it, and that was 2 years ago, then I guarantee you we're probably going to have more than 125 billion connected devices, and by 2030. And then at the end of the day, all of this is happening on one planet. And what you can say is that with the massive amounts of data that are hitting us every day, all kinds of data, infrastructure, IoT data, ERP systems. What is going on? It's not us. This has not been. Sorry. All right. Well,
I'm gonna go for help.
That's cool. I'll keep talking, and because I think you guys get the idea. That I've been telling people that there's really kind of a compound primary key for how we as a species are going to be able to investigate, analyze, and make use of all this massive amounts of data that's all around us. And that compound primary key is really, it has to do with who a problem is affecting, what assets are involved, where they are on the planet, and then you could actually say what time or duration that this event or that this incident is happening and covering over. I'm just going to go forward a little bit to remind myself of what's here, but I'll keep talking, because some of these slides are just for eye candy. I joined Esri back about 4 years ago, and I started as the 3D PM. They thought that I was going to be the PM for City Engine and 3D Analyst, but I had been essentially the 3D PM for infrastructure at Autodesk for several years before that. And I already knew that 3D Analyst and City Engine were trains on tracks, and they didn't really need any help. But what I also knew is that Esri needed an actual 3D story across the platform. So that's what I focused on, and as we can all tell by the videos and everything else going on the main stage and in the talks, there's been a huge explosion of 3D here. The number one feature request that I got, starting pretty early on here, was for better BIM-GIS integration. At the same time, really early on, I had an exec tell me that we would never have to worry about BIM information in ArcGIS. Well, guess what? 3 years later, we read Revit files and we have a building scene layer. And the demand for that came from the fact that we released this open specification called I3S that we started saying was for massive amounts of data streaming through over the web and for distribution to clients like web and mobile, which we have actually made a lot of that happen. But as soon as we said we could handle massive data sets, I don't know what's going on here. Do you have anything? But as soon as we started saying that we could handle massive data sets, then people started sending entire buildings, trying to shove entire buildings into this data format. You know, maybe I can like Skype over to you or something. This is weird. I haven't had any problems all week, so maybe let's try that really quickly. Are you online? Because I am. Hold on, sorry folks. I will ping Don and we will. I may not be on. Nope. It says you're offline. Are you offline? Sorry, folks. We tested before, honest. That's fair. Yeah, I'm going to Skype to you. So as soon as we started to say that we could handle really large data sets, people started basically shoving whole buildings through these formats that we were coming out with. Oh, Skype, so. And that was a big problem because what we often then got was that the initial scene layer formats and things that we had basically couldn't handle it. We had a lot of performance complaints and a lot of issues that were brought up by customers. So let's see. All right. There, you're there. It says I said hello to you. There we are. Okay. All right, so let me do this. kill your conversation. No, because that'll, yeah. All right, we'll go with that. You guys can see it? It works? Okay, that's better. All right, so let me go forward. Okay, so BIM-GIS interoperability was a big request. Just one anecdote I tell sometimes is that in one survey of our internal audience, I gave them virtual currency to spend. And there were 24 different requirements, only one of which was BIM-GIS interoperability. And the internal Esri and distributor audience spent a combined 75% of their allowable spend on this one requirement. So it was a huge demand. We had performance issues. And we also had other customers starting to say, oh, now that you're doing 3D, you must be able to start to work with engineering and architecture data. This was this really big surprise to the Esri internal community. What my definition of BIM is that BIM is the process for collaboratively creating and using detailed information about built assets throughout their life cycle. When what we know is in reality, BIM really gets introduced because it introduces tremendous cost savings during design and construction, but we're seeing increasingly the demand and legal legislation for BIM usage throughout the life cycle of assets. And that's actually pushing it more into what might have been traditionally called the GIS space. What the Esri community kind of didn't realize was that the classic GIS community is that real world 3D is buildings and infrastructure, right? It's not Jello cubes and billboarded symbols. It's actual bridges and buildings and roads and highways and things like that. If you look at the problems that occur around a city or urban environment or even large rural projects, what you'll see is that all of these different problems typically have those components I talked about earlier. Who is it affecting? Where is it? What is the asset involved? And then at what time scale or at what time did this happen? Okay. There was this classic view that we still use sometimes to describe especially the integration of CAD and GIS. You know, you plan something, you design it, you build it, and you manage it. I really always struggled against that because I've done CAD GIS integration. I used to do enterprise consulting since like the early 2000s. And what happened was it always felt wrong that there was kind of this idea that there was a perfect handoff between the CAD world and the GIS world. Right, so it's too simple. There isn't really this perfect handoff. What we know is that BIM supplies detailed detailed information about assets, and GIS provides information about assets in the context of the built and natural environment. These two things should work together, and that's why a couple years ago we came out with this version of how the asset lifecycle and then the BIM project delivery lifecycle actually are intertwined. Right, cities, utilities, military bases are constantly operating and they're changing. They're planning that change, then they kick off projects that actually execute on that change. Then they have to accomplish affecting getting that change back into providing the services that they provide as a university, as a utility, as a school system or whatever. We find that there are many, many really common pain points in classic BIM-GIS integration. We could probably double or triple this and still not be inclusive of all the pain points. They are really classic, and some of them have been around for years. There have been new ones introduced as different technologies like GIS and BIM technologies have gotten more sophisticated. What we realized is that there was no way we were going to solve all those things ourselves, so we started this partnership with Autodesk. This architecture slide has been really useful to show to customers and users because we have many folks come to us and say, what's the common data environment between BIM and GIS? And really the common data environment is BIM and GIS data, right? It's not, there is no magic new format that we're coming out with that's gonna solve all of the integration pain points. There's a stack of data that owner-operators manage. There are stacks and stacks of data that AEC services providers manage. The Denver airport expansion generated something like 9.2 million construction documents, right? Those are schedules and bills of material and PDFs and CAD files and BIM files and many more things, right? So we're not trying to suck all those 9 million files into GIS. We just want to deliver the right capability, the right data at the right place to the right people at the right time in the life cycle of those assets. Does that make sense, the way that we're looking at it? Okay. All right. In terms of what we have done over the last few years, and there's a mix of past and future here, we started out looking at BIM-GIS integration and the Esri Autodesk partnership as kind of pinpoint inline integrations from one data type to a particular application. That's why you saw us first start to work with, on the Autodesk side, with things like InfraWorks and being able to talk from InfraWorks to ArcGIS using your named user, right? That's a no-brainer, but there's lots of complexity to it. I just learned that I think if you open up InfraWorks today, you might see that it actually says in the dialog that InfraWorks was created by Esri, which is just a snafu, but you know, we have to, it's more complicated than you would think to get these things out. But actually, the initial idea was we just want to connect GIS data to engineers who are doing stuff called preliminary design, or there are different names for it. When I was there, we used to call it infrastructure conceptual design. And then we're going to be expanding that to enable civil engineers and architects access to GIS data for more detailed design and construction data. We are using, so the Autodesk team is working with bringing their connector into Civil 3D, and then Don may talk a little bit about ArcGIS for Revit. We also, in the connecting the dots perspective, we also wanted to enable GIS users to access BIM for visualization, planning, and engagement. The single largest source of BIM content that we had to look at first was really Revit data. There's a lot more out there. Revit isn't BIM, right? It's a tool that participates in the BIM process, but there's a lot of Revit, singular Revit data out there. It's like 75% dominant in the US for architects. The civil transportation market's a lot more heterogeneous, and we do want to look at other formats in the future. And then the other piece is connecting field workers to their data through GIS and BIM processes. You hopefully will see more about that coming out in the next few months to year or so. We hear about Survey 123 and Collector being used in tons of BIM programs already today, and asset management programs too, right, that deal with detailed BIM-like assets. Okay. We also, another outcome of kind of trying to solve some of the data and scalability issues of using this highly detailed data in GIS, we recently came out with a new I3S scene layer. I3S is an open standard that Esri put out in the community in 2015 and then made its way into OGC as a community standard. And we've actually just released the spec for a new specification inside I3S to actually allow you to take whole buildings and store them in a way that you can scalably distribute them over the web, or even take them as a big chunk and move them out to, say, a mobile phone GIS experience, that kind of thing. The building scene layer at one level is just a collection of feature services that are instantiated with cache that allows this faster visualization. But at a different level, it is essentially an object data store for buildings. And Steve and I were talking about this quite extensively the other night. So we have preserved some of the semantic structure of the data that came from Revit. We've got most of the attributes. I think it's mostly just system attributes that we leave out. And then we have most of the geometry, the assets. I think we made some decisions to leave out some electrical and things that I think were...
Just for the first release.
Yeah,
they're coming back in 2.3.
Great, that's awesome. So that's great. We've seen incredibly positive response to this already. We had one customer, a GSA customer, take the initial version and basically line up Revit and line up Pro and go category and discipline by discipline in the schedule and actually say, this is 100% translated, this is 100% translated, this is 67%. You know, they were looking at that for asset management, right? And trying to use the BIM in the life cycle. So this is how we're gonna enable you to use that data. We have other possible plans around that for kind of infrastructure in the future. Don may show an example in a sec. And we've got things we have to improve, like we need materials and other things. If you move beyond the kind of the pinpoint interactions or integrations, The Autodesk team wants to work with us very heavily on kind of building out a joint smart cities story. And I already said earlier that the team that we work on is kind of like the smart cities team at Autodesk. Well, not everything that, or Esri, not everything that Esri does is in smart cities is going to involve BIM or Autodesk, but there are specific areas where we do see them as an integral partner. We are getting a lot of demand around reality capture. Esri does not have a reality capture solution. We may look at things like integrating with some of Autodesk's reality capture tech and possibly others as well. We definitely need to have kind of an integrated story around the use of BIM and GIS together for urban planning, and then moving into design evaluation, and then some of the other good stuff that needs to be done before you actually kick off a construction project, right? And then we also get a lot of demand for these kind of 3D smart cities dashboards. And we have a dashboard capability in Esri. I think I will be looking at, and some others on my team will be looking at, whether that dashboarding capability is sufficient or whether we need to do something that is specifically relevant to the smart cities BIM GIS integration story. I think that's still open for debate. Dashboards are so flexible and there's so many diverse needs. I think it may just be that we are providing some kind of better dashboarding capability to allow you to look at BIM information and say tie out to Forge and things like that in the future. So these are some of the kind of the higher level workflows that we're looking at around the BIM and GIS story. All right, we're going to switch over to Tom, which we don't even have to switch cables now. So there
we go.
All right.
Yeah, so once again, I'm Don, and Chris and I do a lot of presenting both separately on this topic and together, and I think Chris did an excellent job of helping, ground us in the topic. And so, like he mentioned, a lot of the things that you're seeing here will be direct integrations with Autodesk, and but it's not limited to that, right? So the story of moving information and its context within GIS is really the heart of the topic, because we want to share with you the technologies that we're working on, the roadmap, and what opportunities that presents for all of you. We know that in the intersection of BIM and GIS, we can talk about all the different definitions of GIS, but at the core of what I think we're interested in this room is the information and how that information can be shared in the BIM process and as part of GIS workflows. As Chris mentioned, one of the first things that a lot of people jump to right away is the idea that there's this one common data format that will be able to do everything. I think essentially reality is the only database that has that type of fidelity, and as we talk more about sensing and reality capture, some of those things maybe even be more possible. And
I thought that's what IFC did.
We might look there. And so part of this is also fueled by things like IFC or the whole BIM movement, which is a good thing in some ways, that if you digitalize the process, that digital information can be reused and repurposed, right? But one of the problems with that is it's an oversimplification of what's actually happening. BIM is used and is successful because it reduces the ambiguity, it reduces the uncertainty of the design process so that you get benefits in construction. You can do things like virtual design and clash detection, so there's less surprises, things happen in a more timely manner. But that doesn't mean that all the information is in a BIM. So what is a BIM when we talk about information? Or at some point, we really need to talk about what is the digital format of this BIM information, whether it's architectural design data or a spreadsheet, or what's actually in it. And so even one BIM doesn't have everything in it. So a BIM file, a Revit model, an IFC file, only has information that somebody coded into it, or it only contains certain type of information. So a conceptual BIM may just be the look of the building on the site, or even a massing model. That can be a BIM file or a Revit model. A SCADA BIM process is looking through buildings that already exist, and they're pulling out things that they care about. They're not necessarily going into the walls and into the plumbing and up into the roof and doing those types of things. But that's still a Revit BIM file, right? There's the idea of trades BIMs. A BIM file may be just the MEP, or just the structural, or just the foundation. So a BIM file doesn't necessarily even encapsulate an entire building. A construction BIM is really about how things detailed come together, whereas a record BIM may be everything. And that's when people start talking about record BIMs, they want everything in this one model, and they're going to load it up and try to put everything in it. So at Esri, we have to take a look at the state of the industry and then all of these perceived benefits and then the actual benefits and plot a course forward. And so we understand that GIS is not an architectural design system, a tool. It's something that is useful in the BIM process to further reduce uncertainty. It gives you more context for design. There are tools in GIS and the ArcGIS system that can share information out for collaboration and for stakeholder engagement. And so there's real benefit and the two coming together. So we take a look at how do we approach BIM information. We've been able to categorize it from users and people like yourselves into two main buckets. There's the idea that I just want to see it. I want to understand a design that's coming down, or how this new development is going to impact the existing condition, or how the existing condition is going to influence this new design. So visualization, just being able to see it, has real value. And the other is, another bucket, you could say, is I want to use the information to fuel other business systems. I want to look at the features, the geometry, and the actual attributes, and I want to compute things based on that information. So I want that information to become available to me to get my work done. And these two different ideas sometimes have diverging requirements and how information is stored and presented to the user. So as Chris mentioned, as GIS has become 3D, people have not been satisfied with just making 3D symbols. They actually are putting real-world objects into it. And Esri continues to work on our 3D capabilities, but we're not necessarily trying to create 3D architectural design software, right? We're using the tools that we have to provide real benefit. Chris talked about some of the different layer types we're developing, these cached layer formats that allow multiple levels of detail to create experiences for huge amounts of data, like these 3D objects, which are millions of boxes of textured buildings that we can blow through on a mobile device or in a web scene. A similar type of layer format that we have, if we don't freeze, is a mesh. It looks similar sometimes in a cityscape, but this is the idea where you have a continuous surface of the globe. And it's as you move around in it, more information comes into the foreground, and it's less information in the background. So that's the caching format, allows us to stream huge amounts of information. This is a type of data that's normally collected from drones and other types of point cloud information that's generated into a mesh. I mentioned point clouds, so just the raw point cloud information, being able to take huge amounts of LiDAR, mobile collected or aerial collected information, and bring that into the same scene as all of these other 2D and 3D formats. We're also working on a new layer type for what you might call voxels, useful in understanding huge amounts of point cloud type information or voxel information. So we have all of these different things at our disposal, and we're trying to combine them into useful ways. On the left-hand side, we were doing an experiment with our 3D objects layer. We knew that there was going to be huge amounts of information being poured into ArcGIS. And so there was one thing to have 1 million boxes in a city. We realized that with BIM information, there could be millions of things in millions of boxes. And so they took the entire city of San Francisco, they shrunk it down on the rooftop of one of the buildings as some of the early research. On the right-hand side is one of the outcomes of that type of research, which was what Chris mentioned in the building scene layer, being able to, instead of dragging 20, 50 different layers into one web scene, we encapsulated them as a group and then added additional what we call graphic hints to help us move through huge amounts of data even easier. One of the things that we've noticed when we started being able to present this information is that customers have seen their BIM information in a way they've never been able to see it before. That Houston Airport example that Chris showed earlier, the people that were working on that project had never seen all that BIM information together in one place before, and now they were able to see it in their geographic context. One of the patterns that we see evolving from this is because they have access to all this geometry in its geographic context, people are starting to use it as a geographic interface to other business systems. Business partner Indoor Reality on the left-hand side here has a scan to BIM type of process, and they walk through with a handheld device. And they're creating spherical imagery and then recording the geolocation of those setup points, and they've just linked their viewer with the web scene. A similar type of thing is happening here on the right-hand side. Using a BIM-sourced geographic representation in a web scene, and then navigating to the actual BIM document in BIM 360. Again, with a simple link between the two different viewers. The viewer here on the right-hand side being the Forge large model viewer. Another pattern we see is this idea of the connector. So ArcGIS for AutoCAD has been around for more than a decade. And what it is it is the AutoCAD user's interface to the ArcGIS system. It allows you to generate ArcGIS data sets within an AutoCAD file and share it with desktop users. It also is a interface to the ArcGIS platform that allows you to pull in maps and edit feature services. So the ArcGIS for AutoCAD application already provides AutoCAD and Autodesk users with full support of feature services and map services for editing, which would include Map 3D and Civil 3D. That pattern is then being repeated. So Chris mentioned the InfraWorks connector from Autodesk is a similar type of application that allows you to take some of the parametric capabilities in pre-design and link those up with GIS data sets using the attributes of the GIS to hydrate things like roads and site plans and buildings using some of their parametric pre-design tools, where the Esri ArcGIS online data becomes that source. All of this is built on the Esri platform, right? The Esri system that is the same information that you're using to collect things in Collector and Survey 123, the same data that's being managed or visualized in dashboards is the same information that can be used in InfraWorks and AutoCAD. And we're looking to replicate that pattern. Another one of the aspects is making information more accessible to the GIS user. So in last year, sometime at the early release of 2.2, we were for the first time able to reach into a Revit model and pull out the geometry and attributes of information directly from a Revit file. And so we repeated another pattern like we do for CAD. When we can also read an AutoCAD DWG file or a DXF file or a MicroStation DGN file. And when we do that, we read it as a GIS data set. So essentially converting it in memory. And we just use our GIS toolbox on that data set. And we break it into, in the case of a CAD file, into its geometric types that we understand, points, lines, polygons, the 3D object we call multi-patch, and the text as annotation. With ArcGIS for AutoCAD, I mentioned you can create ArcGIS data sets within the DWG file, so you will see attributed feature classes in a DWG file as well. For a Revit file, it is actually more structured than a CAD file. And so we were able to make a one-to-one correspondence between the categories in a Revit model and ArcGIS feature classes with their attributes. So the structure that you see in ArcGIS is those Revit categories. So we collect all the walls together as a feature class, all the windows as a feature class, all the doors are a feature class, all the structural columns are a feature class. So I know here in Revit, I can create custom attributes. So I can rely on the fact that information that I've chosen to include in my Revit model will be accessible to me in ArcGIS. Whether it be an asset number or a omniclass classification, that information that I choose to encode in the file is the information that ArcGIS prefers when it reads the file. So I had added an attribute to that roof element, and I can reach into the Revit model. When I pull that roof, those roof elements into ArcGIS, I have access to its geometry, but also to all the attribute information that was encoded on those objects. When I read the Revit model, it already is an ArcGIS data set, so I can do things to it with my toolbox. So in ArcGIS Pro, I can do things like geoprocessing. I can say copy features and save it to a geodatabase. Or in this case, I'm using a geoprocessing command called export to CAD. Kind of an unusual choice, but what I'm doing is I'm taking this GIS information that's sourced from a Revit model and I'm exporting it to another format. In this case, the format I'm exporting it to is an AutoCAD DWG file. It's going to create for me 3D GIS objects in an AutoCAD file. And I know that as part of the interoperability solution at Esri, whenever I export data into an AutoCAD file and I have ArcGIS for AutoCAD on my AutoCAD application, I see not only that geometry, but also attributed GIS feature classes. So in a sense, this Revit data has actually lived through that process, and I see those attributes that I encoded there, but now inside another application. Along the lines of ArcGIS for AutoCAD, ArcGIS for AutoCAD, in its next release, will have a stronger tie to ArcGIS Online and Portal. One of the great side effects of that is going to be access to hosted services, so it adds a whole new level of collaboration. We talked about the fact that this BIM or Revit information can live on into other experiences. So that information that I encoded back in Revit, I can use directly in Pro. I can use it for analysis, computations. I can share it out for visualization and collaboration purposes, to create these streamable experiences on different devices, but still have access to that information that I can then link to other business systems. So kind of a general pattern that we look to replicate. We have the idea that we know that BIM information is in a lot of different formats. So it's in a spreadsheet, it's in a CAD file, it's in a Civil 3D file, it's in an inroads MicroStation file. We need to be able to pull this information to make sense of it in GIS. And we also need to be able to share with people at a file-based level. We know that if we create plugins, we can help people create data that's more aligned with the GIS workflow, right? So we can help organize unstructured CAD files. We can guide people in the creation of Revit models that include data that we care about downstream. And when we do that, if we have tools that can read these files, we can make sense of them and use our toolbox to then do smart things with it. We also know that if we can read that information, we can plug it in to the rest of the platform to make it accessible to the entire GIS enterprise. So that Revit-sourced information is available in my phone app, my dashboard, in my ArcGIS Pro session, in my ArcGIS for AutoCAD session. The ArcGIS platform makes that information shareable. Those plugins, if they're smart, can also make connections to this same information to create these round trip or these workflows that are connected. Creating these applications that also can contribute or create this information directly through services makes a lot of sense. We have higher level GIS objects that we also can take a look at. So some of the work that we're doing or looking forward to now is how do the higher level organized objects in things like Revit pipe systems or electrical or MEP or Civil 3D pipe networks or parcel information, how do those tie together with higher level GIS objects like utility network or parcel fabric or roads and highways? And so part of the, the forward-thinking work that we're doing is how does civil 3D information move back and forth? How can Revit or architectural design information smartly move in a pattern that's connected, both to the AEC applications that are generating that information as a source of information, but also pulling GIS information into those applications as GIS context. A lot of times, a GIS has all of the information that become the design constraints for the designer working in InfraWorks or in AutoCAD or in Revit. So looking at those possibilities. So one of those efforts that we're currently working on is a research project for Revit. What would it be if I could use mapping information in my Revit model to help me geolocate things, type in an address, add the map, define my coordinate system, locate the position of the corner of my building, save that information so that when this information comes into ArcGIS Pro, it's already georeferenced. It just comes into a place where it needs to be. What benefit would there be to pulling in more information inside the Revit application for things like terrain? What if I want to get an idea what this terrain looks like? I want to know where existing utilities might be. How is it positioned in the context of the roadway network? That might help me just make decisions about how I orient my building or what side of the building I make connections. Other work we hear or feedback that we're getting is it's great, this Revit information is all good, and like Chris mentioned, there is a large market segment that serves. We also know that internationally, especially in Europe, there's a big push or big movement that has already gone into IFC, and so currently we support IFC through the data interoperability extension, but we're also looking forward to possibly reading IFC file information directly. It would be in a similar way that we would for Revit models. Some of the additional benefits of that are there are more IFC types that maybe tend toward things like civil infrastructure that we might also be able to pick up. But again, that's just on the horizon. Other work, we recognize that BIM is, really civil infrastructure is really a part of BIM. One of the other projects that we are embarking on later in 2019 is directly reading civil 3D files as enhanced CAD drawings. So you know how I pull points, lines, polygons, and if there's any organized information from ArcGIS for AutoCAD, I could pull that in. We're also looking at the civil 3D objects directly, things like alignments and pipes and other higher level objects, and giving you access to that information directly.
All right, so we'll go back to the...
So with that, Chris has some wrap up here.
I should stay sharing. All right, so I wanted to show you folks something, and just to let you think about where we're going and what we're doing. So what you see right now is, I think it's like 6 gigs of Revit data streamed for Houston George Bush Intercontinental.
This is his phone that he has in his lap right
on my phone, right. So, and I don't have, I'm just using the conference center Wi-Fi, and there's nothing special that I'm doing here on my phone. It's literally my standard Chrome browser on my phone, looking at ArcGIS Online, streaming in this new scene layer this is the older scene layer format that we talked about. And it may be sometimes if I zoom around, we might see, actually it's pretty good. You can see some assets will pop in the background. Somebody at another conference that I was at recently, Don didn't present with me on that one, listened to me talk about kind of these fundamental data layers and things like that. And he told me that it sounded like we were building an excellent 19th century steam engine when what we really needed was an airport. And I understand that perspective, that there's a lot of expectation out there around where we need to go to accomplish asset management workflows and to integrate BIM information, detailed design and construction data directly into the lifecycle asset management process. And people are able to look at this and to start to say, well, if I can click on, this, or tap on in this case, tap on this asset, and I can actually see the actual detailed attributes, metadata that came from my Revit file. Well, why can't I just have that Nirvana asset management system already? But what I would simply say is that there are so many fundamental missing connections between the BIM world and the GIS world that really it's the project delivery world and the asset management world that we are having to basically start to solve and address. That I think many of our customers and users don't really understand that. They especially in Europe, no offense to any Europeans here, but I find that there's a lot of top-level language around how BIM is for life cycle. And when I go meet with like transport ministers in Germany or similar folks in France or the UK, they've got the top-level messaging in their head, and they've bought into it without realizing the difficulty and the lack of historic connectivity between these two domains that have really differentiated substantially in the last few years. So I actually, one of the things I've told people is I'm always shocked at how much bleeding edge tech that I've actually worked on since I joined Esri. It's definitely not a sit in my wheelchair and cruise through the rest of my career kind of situation. We are constantly having to deal with complicated problem sets that actually have not yet really been solved. Just to show you the other example that I've got here is this is actually the building scene layer. So this is the Loma Linda VA hospital. Let me see if yeah, so there's one view of it that I don't really like, which is we do this building exterior thing. But if I go back to the BIM, the actual BIM attributes, they load, or the BIM data, they actually load really fast. So this is a bunch of mesh data coming out of Revit. And then if I've got some little bookmarks in here, I can go inside the building again. And this time I can also tap on this and I can see that I've got all the metadata, just like I did in the last one, except in this case, there's a single entry point to this. This whole building is there's one REST endpoint. Like this is the Dev Summit, so I can talk about REST. So there's one REST endpoint that you can use to dive into and start searching through and accessing the data in this scene layer. Where we will go in the near future, so the next release to 2 releases of Pro and Online and Enterprise, is that we will actually hook up underneath this a set of feature services that actually allow you to do things like hook up collector to the objects in this BIM layer, this building scene layer, and actually allow you to start to do things like collector or survey 1, 2, 3, right? And actually allow you to do things like directly change the attributes in that scene layer, right? In that BIM model in GIS, from simple lightweight apps like Survey 1, 2, 3 and Collector. So we are actually trying to help you build that airport, but because we're not going to be able to do everything in that domain. But I just wanted to show you these things, and it's just fascinating to me that I can do this on my phone now, right? I mean, there's no way that a couple of years ago that I would have said, oh, I'm going to actually have the entire Loma Linda VA hospital as a Revit file translated into GIS, accessible through the cloud on my phone over conference center Wi-Fi, right? And have it be effective. It is very effective. The number one demos for us over the last couple of years have been these kind of BIM data demos on first on desktop and then now increasingly on mobile, especially with the high level kind of exec types in our AEC service provider customers. All right, I thought I'd just walk really quickly through some of the topics in an article I wrote a few weeks ago that actually was based upon a conference talk. And just because maybe you can just hear some of my perspective live on some of it. And these are, I probably changed the words and a little bit of the sentiment slightly to get it into written form on the blog. But these myths and realities kind of came out of many years of working around first CAD to GIS integration. The first CAD diagram I ever put online was a plat map as a scan bitmap image in 1997 in a Java 118 applet. So, I've been touching this space, not quite as long as Don has, but for a long time as well. All right, so there are 5 myths about BIM in the GIS world. My favorite one is when people tell me that BIM is for facilities management or that it's for 3D modeling, and then my third favorite is that people tell me that it's only for buildings. It's simply not true. We do hear also that BIM provides GIS features. Micah at, I don't remember where he is right now. I can picture the company logo, but I can't think of the name. Somebody emailed me or emailed in a couple weeks ago that I was wrong about this second item here, and that actually you can find GIS data in lots of Revit models. And I wrote back and said, well, I'll give the guy $200 if he can find 5 Revit models from 5 customers that have building shells, building footprints, floor plans, and rooms and spaces that I can use immediately in GIS. You know, Don, your comment was something like my $200 is safe or something like that, right? Yeah, so all right. There's this idea that there could be a single file format that can provide BIM GIS integration. And then there's this idea that you can't actually directly use BIM content in GIS. Well, I think I've already shown you that it's possible to do so. And then finally there's this idea that the GIS is the perfect repository for BIM information. I argued very heavily with the Dev Summit, the plenary folks, because they had a slide that was Revit into Pro with an arrow into ArcGIS and online. And I said, there's no way you can show that. You know, we are not turning ArcGIS into a doc repository for BIM information, right? Back to my 9 million construction document comment. All right, so the reality is that BIM is a process for optimizing cost and time during design and construction, right? We ideally with data continuity into asset management. That's where Don had the great 1D through, or level 1 through level 8 BIM, right? The ideally is like the level 7, 8 stuff. Really, the UK is at like level 3, right? And they're still saving 20 to 30% on major construction projects. So they're happy, but they're still trying to move up into level 8, right? In terms of BIM providing GIS features can be created from BIM, but often require extra information or calculation that is not in traditional BIM design data. One of my favorite types of customers to work with is airports, because they all have, or most of them, the more forward-thinking ones, have rigid drawing validation. Drawing validation allows standardization of your BIM data, right? And they have to have multiple types of drawing validation. They have to do it for their civil data, they have to do it for their architectural data, right? And their plumbing and MEP and all that stuff, right? So they have already got in their head that they've got this big program for an airport that's gonna last 100 years, they better get standardized data. Well, the one overlay we need to add on to that is they need to start thinking about what other metadata needs to be in those drawing standards to make its way into the life cycle. For example, in Revit and in IFC, you have a place to store a building name that 95% of the time is not filled out. Well, if you want to shove another, you put one building into a building stand there, you want to push in another building in the classic, stack order, right? Well, if you want to know that there's building 1 and then there's building 2, then your drawing standards better say that you actually filled out the metadata saying that this was building 1 and this was building 2, right? So basic stuff like that, but there's a lot of data workflow issues that we have to overcome as a species. This idea that there's a single file format, there's no single file format that can provide BIM GIS integration. There's a lot of open standards folks right now trying to say that you can use CityGML as the perfect interchange format. All I will say is that will allow you to have a one-directional, extremely lossy view on your BIM data that will last you for your first project with it, and then you're going to run into a bunch of feedback from other users that says it's inadequate, and you're going to have to go back to the drawing board. Okay. Well, we already showed that you can directly use BIM content in GIS. This project on the left was freaking fantastic. It was an IFC and it's kind of using what we've done to kind of overload what we thought you would do, but users do that all the time, right? So Aegis is a big French construction company. They were working with civil infrastructure projects in a couple different software systems. They basically just saved it all out in the IFC, then used Revit to read in the IFC, and then used Pro to read in the Revit data. And that's a little bit of a hack from where I think we want to go with the infrastructure type data, but that is a massive tunnel project that you're looking at that now is able to be used in some sense in GIS. So pretty exciting. And then this idea that GIS is the perfect repository for BIM information, it's not a repository for complex version BIM design data, supplementary documentation, nor is it ever going to be the stamped legal record for construction. And when I first gave this talk, there was a guy in the front row who said something like, "Oh my gosh, you're right." And out loud enough that other people could hear. And later after the talk, he said that he'd had people for 2 years arguing with him in his organization from the IT side that he should just be scraping all of his BIM data into GIS and throwing away all of the design docs. And when I said this, he said, "We can't do that because that's all our legal record." And so, there are nuances to this that if people just look at it as file formats and data, they miss. In reality, they're much more complex. Like I said, it's really a problem set of kind of smart asset lifecycle management and integrating that with project delivery, right? And that's really the complicated story that we have to talk about. All right, so you guys can get these slides after the show. Oh, you know what? I just wanted to show this voxel thing again. Don already showed it. The reason that I wanted to bring it up is because we are, oops, all right, it's not gonna play now, that's okay. We are actually doing some things that at first seem kind of sciencey or maybe not relevant to this story. But actually, there's a lot of civil and geotechnical engineers that want to actually have volumetric representations of subsurface aquifers, geology, other things. And we have other efforts in Esri that actually will intersect with some of these BIM plans. And I'm quite excited about some of this stuff. All right, there's a lot of stuff that we are doing in the future as well. We've rolled out a lot of functionality. I mean, I already described how much our jobs have changed in the last few years. I mean, 65% of my time these days is spent talking about BIM and GIS. We're rolling out new urban planning products. We are doing things to have better materials and things like that in ArcGIS. We've got mobile 3D now. There was none for the first 3 years of my existence here. I talked about the voxel stuff a little bit. We're even rolling out a new packaging format for big scenes so that you could literally take a terabyte or 2 or 3 or 8 into the field of data, into the field on a laptop, and actually have a highly performant 3D experience with an app that you create or with one of our apps. And then there's lots more exciting stuff coming down the road. We just bought this indoor positioning systems company. I definitely want to have the blue dot in my Revit model as I walk around a campus in the not too distant future. We're going to work with them. They literally just got acquired. We're going to work with them to figure out how to get their tech across ArcGIS for use in a variety of applications and SDKs so that you could build your own applications with it. And then there's a lot more that we're planning as well. All right, we've got a couple minutes left for questions. I'm happy to take some, and Don is as well. So, yeah, yes, sir.
Just a question on the schedule of IFC support.
So the question is, what is the schedule for IFC support?
Well, it's I'm interested in some more details on the versions of IFC formats and what capabilities. Read some parts of it, write.
Right.
Yeah.
Right. So the tech that we're looking at to read IFCs is coming out of the ODA, and so they have challenged themselves to be the best IFC, reading capability. The first crack at it that we'll get is probably late 2019. So as far as what versions of IFC that we'll support and what profiles, it's kind of yet to be seen. But our first crack at it, we won't even be able to start working on it till toward the end of 2019. But that group is pretty capable, and so they've been working closely with BuildSmart and other international sources to really pump some energy and investment into that capability. That's kind of our plan would be to pick it up from there.
Yeah, and there's a lot of I would say, confusion in parts of the industry about what's in IFC. I was in a conversation with one customer not too long ago, and I pointed out that some of the things they were talking about didn't exist in IFC yet, because they were talking about some of the proposed rail and other standards that just haven't made it. It's actually not in the spec, and that's another whole issue, is just even finding out what a particular customer means by IFC. As Don said, a lot of it is actually historically architecturally centered. It came out of Building Smart, but now they're getting pushed to do a lot more. Yeah, Steve, go ahead.
2 questions. One, do you have an SDK interface into your Revit to feature service? If we want to queue up 5,000 buildings and do it, can we do it through a Python API?
Right. So do we have an SDK interface? So today, I think that yes. I think the answer is yes. The GP tools, it's basically GP tools that are used to process that stuff. But I would have to say the whole workflow of loading and then cooking, Don, can you do that
so
with Python?
so the capability is a data source. So using the ArcGIS Pro data source, you can open up that information and use it in geoprocessing. We are currently working on ways to help you put together multiple buildings for a campus. Right now, the way that I do that is just with GP. I do copy features or feature class to feature class and do merge and append, and then I take that information and I build 3D objects layer like the airport that you saw. We also want to be able to take advantage of the new building scene layer. So we need we want to be able to build a helper tool that can take multiple Revit models and put them into one building scene layer, which ends up being a campus layer.
I think I might have mentioned the other night that we don't yet have the append capability in that building scene layer. So that when that happens, then I think, because you've got this use case where you want to shove a whole lot of data.
Yeah, and so then you're just going to be accessing that GP tool however you want to do it, through Python or through other methods of accessing that capability.
I would say stay in contact with us, and in the next 6 months to 8 months, we should be able to do that. Go ahead.
And the second part of that is Bentley doesn't share very well with others. Are you working on a relationship with Bentley to get their civil data?
We're on record, or we're recorded here. I could talk to you a little bit about some of it in a different context. I have been in Bentley's offices. I think the ODA libraries maybe have some. Do they have DGN or something like that?
No, so I mean, from a DGN perspective, that's something that we continually want to improve and update. So the information that's in a DGN file, we cyclically work through it and to pull in more information out of it. So in the same vein as Civil 3D support, there's lots of stuff in a DGN file that we'd also like to be able to pull out and make available to you.
Well, we're specifically interested in the intelligence, the horizontal alignment, vertical alignment, pipe networks.
Yeah, I think the same thing. It's going to be a path of probably adopting it first in Civil 3D, and then we'll have really done all the work that we need to do for some of these other things, and then it'll just be a matter of getting access to them through our tech.
Yeah, they're promoting their new iModel stuff, and they have opened it up so other people can read it.
That's a great point. So if you do have customers that can work through iModel, the data interoperability extension in this latest release is adding support for iModel, which is be another way to get at that intelligent microstation data.
All right, another question? Others? I think there was at least one more hand. No? Have we answered all the questions around BIM, GIS, interoperability? I'd be shocked. But go ahead, Steve, if you have.
It's not a question, but just information. The roadway IFC spec is in development right now. It's supposed to be out around the 2020 timeframe, to where you will have horizontal alignments, vertical alignments, roadway networks included in the IFC.
I'll tell you, even Autodesk has actually talked with us about using IFC as an interop format because it's so complicated. And so we definitely, it's probably the #1 demand that we get outside of some of the Autodesk stuff that we're working on is for us to be able to consume IFC. So, and we get the Bentley question a lot, and we get a few questions around a few others as well. And Bentley, go ahead.
Since we're being recorded, my views are mine and don't represent the company.
No problem. You're good.
Yeah, and just know that, we do support IFC through the data interoperability extension and FME workflows.
It's a little cumbersome today for folks. So. All right, well, thank you very much. The slides should be posted after the show. It's definitely been a pleasure to see so many people on a Friday morning on the last day of Dev Summit, and hopefully we will have even more for you next year. So, all right, take care.